Everyone, so today we have to talk about dimensional analysis. Okay, this is just conversion of units. You're going to be converting a lot of things pretty much from like grams per liter to maybe grams per milliliter. You might be going from meters to nanometers. Okay, these are easy ways to do this with dimensional analysis. It's really just looking at your units and manipulating them to get to another brand of units. Okay, so let's get started on this. So dimensional analysis is just going to start out with some examples and show you my process from there. So say we have something like 2.83 years and we want to go to days. Okay, you might be able to figure this out on your own, but let's go through the process because when we get to more difficult problems, this process will come in handy. Okay, so we got to go from years to days, one unit of time to another. So what I like to do is start out with what we're given. What we are given is 2.83 years, okay? So I write down what they gave us, and then I use my handy-dandy friend, the multiplication dot fraction bar, okay? So this just helps me lay out my units a little bit, and what I'm trying to do is I'm trying to get rid of years and convert it to days, okay? So whatever is on top here, which is years, is what I'm going to put on the bottom for my units, okay? That way they cancel out and I can transfer it to a new type of unit. Well, years, right? What can I convert years to? What's something that I know about a year? I know how many days are in a year, so I can just do a straight conversion from years to days, okay? So what do I know about years and days? I know that for every 1 year, there's 365 days. Now if I look at this, years on top, years on bottom, those could cancel out. And now all I have to do is multiply my numbers on top divided by my numbers on bottom. So this is on top. Technically, it's pretty much like 2.83 over 1, right? So all I'm doing is taking my top numbers, which are 2.83, times 365 divided by my numbers on bottom, which is just 1. And I should get the answer of 2.83 times 365 is 1,032.95 days. Okay? So that is just the basic dimensional analysis. Okay, we're just going from a unit we know, or taking a conversion we know and using it to get from one unit to another. So that was pretty simple. It might have been even more complicated because in your head you could probably just say, oh, I'll just times that by 365 days and I'll get my answer. Okay, but let's do something where maybe we get a little bit more confusing. Okay, and this process will actually come in handy. So let's say that I have 7.22 days, or 7.72 days, and I'm trying to go to seconds. Okay, this might be a little bit more difficult. I might not know how many seconds there are in a day. Okay, I do because I do this all the time. But let's try to figure out this with our dimensional analysis process. So again, I start out with 7.72 days, and I do my friend multiplication dot fraction bar. All right. Again, this number is technically on top. Units are on top, and I'm trying to get days cancel out. So I'll go ahead and put days on bottom. Now, what do I know about a day? That reverts to time. You might not know how many seconds are in a day, but something that I do know about a day is how many hours are in a day. Okay, so I know a conversion for days to hours. I know that for every 1 day, there are 24 hours. Now, my days are canceled out, and now I'm left with the unit hours. That'd be great if we were just trying to figure out hours, but we're not. We're trying to figure out seconds. So now I'm going to do another multiplication dot fraction bar. Okay, I'm doing the same thing again, right? I have hours on top. I'm going to put hours on bottom. And what do I know about hour? You might know how many seconds are in an hour. But say you don't, what do you know about hour? Well, you know that there are a certain amount of minutes in an hour, right? You know that there are 60 minutes in 1 hour, okay? Cancel out hours and we're almost there, right? We now have made a conversion to minutes, but now I gotta go ahead and make a conversion to seconds. So one more MDFB, multiplication dot fraction bar, minutes on top, minutes on bottom, so they cancel out. And now I definitely know how many seconds are in a minute, right? For every 1 minute, there are 60 seconds. So now, as you can see, we started with days, and through crossing out days and hours and minutes, we got to just units of seconds. Okay, so now to finish this all off, we multiply everything on top divided by everything on bottom. So on the top, I got 7.72, I got 24, and I got 60, and I got 60. Divided by everything on the bottom, which are just a bunch of ones, which don't really matter, right? Because anything divided by 1 is just itself. 2 divided by 1 is 2. So I'll go ahead and I'll plug those all into my calculator. 7.72 times 24 times 60 times 60 divided by 1 times 1 times 1, which is just 1. And I will get 667,008 seconds. Okay, now let's put that in scientific notation just for a quick refresher, right? Decimals here. I'm going to move it 1, 2, 3, 4, 5. Let me redo that. 1, 2, 3, 4, 5. Right now I just got one non-zero number to the left. So I have 6.67008 times 10. I moved it left 1, 2, 3, 4, 5 to the fifth. I keep it positive because I moved it to the left. And if we were doing sig figs, we started with 7.72. Let's see, this has 3 sig figs, 2 sig figs, 1 sig fig, 1 sig fig. So our answer is just going to have 1 sig fig. So the closest way to get to 1 sig fig would just be to simplify this to 7 times 10 to the fifth, right? If we are doing sig figs. In this situation, we're not. But just a quick refresher on all that stuff. Let's get a little bit more difficult, okay? I have just been giving you one aspect, just like days to days to seconds, or years to days. Okay, now let's do something where it's like kilometers per second to miles per hour. So let's do something like 100 kilometers per second, and we want to go to miles per hour. Okay, and the only conversion I'm going to give you is that for every 1 kilometer, it equals 0.621 miles. Okay, so again, I can't do this in my head like maybe I could have done with years to days. This is a little bit more difficult. So let's start our process of kilometers per second and multiplication dot fraction bar. Okay, this 100 kilometers per second is pretty much 100 kilometers for every 1 second. So pretty much what we're doing here is we're doing 2 separate dimensional analysis problems. We're doing one where we're changing kilometers to miles, and we're doing one where we're changing 1 second to hours. Okay, but let's just focus on one thing at a time, and let's do just kilometers, right? That's a unit of distance, so we're trying to change that to a unit of distance. So again, kilometers is on top. I want to cancel that out. So I'll put that on bottom. And what am I trying to convert it to? Miles. Okay, luckily I gave you the conversion, and we can just plug in miles on top. And I know for every 1 kilometer, there's 0.621 miles. Okay? So right now my units are miles per second. But I don't want miles per second, I want miles per hour. So now let's focus on just that 1 second. Let's convert that guy. So multiplication dot fraction bar, okay? We've been usually putting stuff on the bottom to cancel it out, but in this situation, seconds is on bottom, right? If I put seconds on bottom here, when I go to multiply them, it's just going to make it seconds squared. So I can't have that. I need seconds canceled out. So since I have seconds on bottom here, I'm going to put seconds on top there, okay? And then what do we want to change seconds to? Hours. If you don't know the conversion from seconds to hours, you could go from seconds to minutes, and then you could go from minutes to hours. But here, I'm going to just tell you the conversion from seconds to hours since we're going to be doing that quite a bit. I know for every 1 hour, there are 3,600 seconds. And now, look how nice that is. Those seconds cancel out, and the only unit I'm left with now are miles per hour. So now we just multiply everything on top divided by everything multiplied on bottom, and we'll get our answer. So we got 100 times 0.621 times 3,600 divided by everything on bottom, which is 1 times 1 times 1. Right? So I got 100 times 0.621 times 3,600, okay, divided by 1, and you should get something like 223,560 miles per hour. Okay, so you're flying if you're going 100 kilometers per second. Okay, so let's do one more example where we're messing around with that, and we'll make it a story problem so we can make it a little bit more challenging. Okay. So I can run a mile in, let's go 7 minutes. That's pretty accurate. Okay, I can run a mile in 7 minutes. What is my average speed in miles per hour? What is my average speed in miles per hour? So here, I know that I can run a mile in 7 minutes. What is my average speed in miles per hour? Okay. So I always start with what I'm given. What have they given me so far? They've given me 7 minutes and a mile. Okay. So again, we're trying to get from miles per hour, but right now I only have miles per minute. I know I could run 1 mile for every 7 minutes. Okay, so I could run 1 mile per 7 minutes. That's what they've given me. Try to write it in our dimensional analysis form where we have it in a fraction. Okay, and we are trying to get to miles per hour. Okay, this is nice because we have already gotten our distance unit figured out, right? Miles per hour, miles over hour. We already got miles on top. So really all we need to do is convert minutes to hours. Okay, so we're focusing on minutes. I have minutes on bottom. Remember, I want that canceled out, so I'm going to put minutes on top, right? And I know a straight conversion from minutes to hours. I know for every 1 hour there are 60 minutes. Okay, this works out nicely. Our minutes unit cancel out. Now I just got miles per hour. Multiply everything on top divided by everything on bottom. 1 times 60. 7 times 1. That will give me an average speed of 8.57 miles per hour. Okay? 8.57 miles per hour. Let's do one more quick one, just to kind of get you ready for what's going to be on our worksheet. We have, say, I have 2.2 pounds Let's go with paprika. And paprika sells at 10 cents per ounce, right? How much money can I make in dollars? Okay. So that's just my dryer going off. Take a second, look at this, and think, what can I do? Pause the video and think, where should I start? Okay. So I need to get to dollars at some point. Okay. So I'm trying to think backwards here a little bit. I need dollars. Well, all I have right now is 2.2 pounds of paprika. Okay. But luckily, I know that paprika sells for 10 cents an ounce. Okay. So if I could somehow convert this to ounces, I could figure out how many cents I can make. And then after I figure out how many cents I could make, I could figure out how many dollars I can make. So let's first off get this guy to ounces. If I can get this guy to ounces, I can figure out how many cents I make. So starting out with 2.2 pounds, right? Multiplication dot fraction bar, right? And if you don't know, there are 16 ounces in a pound. I think, yeah, 16 ounces a pound. Okay, so I'm going to put pounds on bottom because I want them to cancel out. And luckily, I know a straight conversion from pounds to ounces. So for every 1 pound, there are 16 ounces. Okay, cancel out pounds. Let's figure out how many ounces I have. I have 2.2 times 16. I have 35.2 ounces. Okay, now here's where I want you to get good at using unit manipulation. Okay, so I know how many ounces I have, and I know how many cents I can get per ounce. How can I manipulate these units to just end up with cents? Okay, you might be thinking, okay, I could take 35.2 ounces divided by 10 cents per ounce. This is wrong, by the way, and let me show you why. Well, let's look at our units, right? Let's remember that anything in the denominator of the denominator, so numerator, denominator, numerator, denominator, denominator of the denominator, okay? Anything in the denominator of the denominator, we can move it into the numerator position. So if we were to do that, our units would end up being ounces squared over cents, and that's not what we're looking for, right? So we know we shouldn't divide those two numbers, but let's say that I were to multiply these two numbers. So say I was going to take 35.2 ounces times 0.10 cents per ounce. Well, look, this is just like our dimensional analysis almost, right? I got ounces on top, I got ounces on bottom. Well, what are those guys going to do? They're going to cancel out, and look what I'm left with. Cents. I'm left with cents. So how nice is that? So I take 35.2 times 10. I end up with 352 cents. But remember, I didn't want cents. I wanted dollars. So I'm going to go ahead and I'm going to change. I know that if I have 352 cents, for every, I'm going to do dimensional analysis and be a pain. I know for every 100 cents, I get $1. Okay, so I divide by 100, and I'll end up with $3.52. Okay, so that's dimensional analysis. Make sure you're using your units, getting comfortable with using those units, especially making sure that those units match up. Okay, have a great day, everybody.